All right, this is lesson 4-1, where the title is Write and Evaluate Algebraic Expressions. On this video, I'm going to try to stick mostly to the examples, and then the discussion part will be in class, but I thought I'd go through a little bit of it here at the beginning. The essential question here, how can algebraic expressions be used to represent and solve problems? Our goal here in this topic is to be able to set the stage for topic 5, which is going to be writing and solving equations and inequalities. And so this is kind of the precursor to that. It's just kind of setting the stage for it. We need to be able to represent situations where there's an unknown in it, or there's something that can change, so there's going to be a variable in it. Quickly go through some vocabulary here. I'm going to discuss it. I'm not going to do a bunch of the writing here. We'll do that in class. But when we're talking about an expression, we're just talking about a math phrase. It could have numbers in it. It could have, if there's unknowns, it could have variables, and then it has math symbols. So it could have the operation symbols, it could have parentheses, and it can even get more involved than that. We're going to be sticking mostly to numbers, symbols, and then variables. There's really two kinds of expressions we're going to be dealing with. Numerical expressions don't have any variables in them. Numerical, that's adjective form of number. It is a number expression, so it has numbers and math symbols. And what we can do on those is we can follow the order of operations and actually calculate what that is equal to, and that's called evaluating. When we're asked to evaluate an expression, we just find out what it equals, but we have to always follow the order of operations. So then we have an algebraic expression, and there's some examples of these down here. Algebraic expressions can have numbers and symbols, but it has a variable in it as well. So if there's a variable anywhere in it, it's called an algebraic expression. Now, interestingly, some textbooks call it a variable expression. Perhaps that's a more simplistic name, but it really means the same thing. In class, we're going to do a little discussion on this problem here. So we'll do a quick discussion here. I won't go fully into it here. We'll hop over to the examples. But this little solve and discuss it here. Mr. Ramirez's class was playing a game in which students need to match sticky notes that have equivalent expressions. The word equivalent means just has the same value. So how can you sort the expressions into groups? We're trying to get them so that they are equivalent. So if we just take a look at them, if we take a look at, let's say this one here on the far left here, it says 8p plus 2p minus 8. So the terms that have p's in them, they can be combined, and that's one of our lessons we'll be dealing with. If you think of them as actual objects, this is like 8 pizzas plus 2 pizzas. That's 10 pizzas. And then this minus 8 has nothing to do with the pizzas. It doesn't have a p in it. But if I put these two together and got 10 pizzas, or 10p minus 8, that is exactly what I have right here. So these two little post-it sticky notes are equivalent. They have the same value. And so if we go kind of looking around for certain things here, like if we look at this one here, we have a 5p, and then later on there's a 3p, and it's adding. So if I put 5 pizzas with 3 pizzas, that would be 8 pizzas. And then this plus 8 doesn't have a p in it, so you can't combine that with the p terms. So we have 8p plus an 8. And then if we look at some of these other ones, I'm looking for one that would be equivalent to that. And we look at right here. If we look at this, this is 8 of the p plus 1s. 8 times a p plus 1 in parentheses. So we have 8 of these. So if I had 8 of these p plus 1s, I'm going to have 8 p's, and then I'm going to also have 8 1s. And 8 p's is 8p. And then 8 1s would equal 8. So that would be the same thing here. And there's actually another one along the way. So in class, we'll kind of sort these all out and get all the equivalent ones in one group and go on from there. But that's one of the key things, is being able to take an expression and simplify it and find out, is it equivalent to something else? And if we can get it in simplest form when we get to solving equations, that's going to help us out quite a bit. We'll make the equations as simple as possible. So let's get into some examples here. I'm going to turn on the next layer here. And so here we go. Example 1, and then try it is based on that same example. So if we look at this one here, this one is worked out in your book, but I chopped that part of it off so we could work it out here. And the title of it is to write expressions to represent situations. If you're taking notes from this video, it would be a good idea to pause the video and then write down like a title. You can abbreviate things and then write down the key information from the problem. You obviously don't need to write it out word for word or draw the fancy picture and all that business, but it'd be nice if you knew what the problem was about. So here we go. An automatic dog feeder dispenses 2/5 of a cup of dog food each day. What expression can the dog owner use to determine the amount of food left in the feeder after D days, some unknown number of days? Well, if we look at the picture, when it's full, it says that it holds 20 cups of food. So the start of this situation is when the container is, or the feeder is full. And so it's going to start with 20 cups of food. So I'm going to start my expression. I'm supposed to write an expression. I'm going to start my expression with 20, because that's what the feeder starts off. So I'm going to start off with 20. And then it says the feeder dispenses, or it spits out 2/5 of a cup each day. And so in one day, it will spit out 2/5 of a cup, and then the next day, another 2/5 of a cup. And so since it's taking it out of this feeder and putting it into this bowl area, we're going to be taking away food. So the operation I'm going to use is subtraction, because I'm going to take away. And I'm going to take away 2/5 of a cup each day. So I'm going to write that as 2/5, and then how many ever days tells me how many 2/5 take away. So I'm going to do that as a multiplication. So 20 minus 2/5 D, this is how much food will be in there after a certain number of days. And then one of the things that we'll be doing in this lesson is, we're not asked to evaluate anything here, but I could tell you the number of days. And if I told you how many days, then you can calculate how much food is left by using this expression here. So for example, I could say, okay, after 5 days, how much food's going to be in there? Well, if we put a 5 right here, it's going to cancel with this 5. And so this is just going to be 20 minus 2, which would be 18. So if we were to put a 5 days, if we put 5 in there and then calculated 20 minus 2/5 times 5, as I mentioned, the 5s will cancel. So this is just going to be 20 minus 2, which will be 18 cups left. And that's an add-on thing that I just put on there, but we can use this expression. We can find out if I keep putting in different numbers for the days, we can calculate how much is left. And we notice it in 5 days, it used 2 cups of food. Since it's 2/5 every 5 days is going to use 2 more cups of food. So if we think about it, we could pretty logically, I think, we could get to how many days the food will last. And in a later on lesson, in the next topic, we will be able to write an equation. I can say, hey, this food equals 0 when it gets empty, and then we can solve it and we can find out how many days the food will last that way. But we could actually do it with just that expression there. So let's take a look at this. Try it here. On the try it ones, I would highly recommend that you pause the video and try to work it out totally on your own, and then watch it and see if you get what expression I end up with. So try to do things on your own. It's kind of like riding a bike. If I'm always there, my hand on the back of the seat helping you ride the bike, that does not really help you ride the bike. You need to do it on your own at some point. So here we go. Masumi starts with 217 in the bank account. Key thing is it's starting with that. So your expression is going to start with 217. And then she deposits $25.50 each week. So the amount, the dollar amount there is being deposited. That means it is putting it in to the bank account, not taking it out. This food, it was taking it out. Here, we are putting it in. So that's why there's an adding right there. So it's going to be $217 plus $25.50 each week. So it's going to be 217 plus, and I'll see if I can squeeze it in there, 25.50, 50, that's a 50, and it's times W, because it's not just 25.50, it's 25.50 each week. So I'm going to take that 25.50, and I'm moderately embarrassed by how messy that is there, so I'm going to erase that. I think I may have done a highlighter there, I don't know, but this is going to be 25.50. Just wanted that to be readable. So it's 20, I'll write it down here, 217 plus 25.50 per week. And so we could say, okay, after 10 weeks, and I could put a 10 in for W, or after a whole year, 52 weeks, I could put in a 52 for the W and see how much money is in the account. So since it was depositing, adding it in there, we put an addition sign. This dog food one, it was taking it out of the feeder, so we put a minus. Now, we need to understand why the W goes with the 25.50, and that's because it was 25.50 each week. That 25.50 is not a one-time thing. That 25.50 is each week. So your variable goes with the part that is repeating or is continuing on. The 217 is just the starting amount. It doesn't have the weeks with it because it's not dependent upon the weeks. So hopefully those two examples make sense. So let's move on to the next one, or next two here. Before we move on to this, convince me, how did you determine which value to use for the constant and which value to use for the coefficient? So the constant is just a plain old number, whereas the coefficient is a number that's in front of a variable. So it's a number that has a variable with it, whereas the constant is just a plain old thing. So on that previous one, the number that's all by itself was that 217. It is not dependent upon the weeks at all. The coefficient one, that 25.50, that number that went with the weeks, since the weeks change over time, it has that variable. On the dog feeder one, the starting amount has nothing to do with the days. So the starting amount, the one that is just a set number, is the constant, and then the one that changes over time, it had the variable with it, so it becomes the coefficient. So let's move on to the example 2. Example 2 is totally worked out, so I'm not going to do any work on it. We're just going to kind of talk about it. It's evaluating expressions. So on some of the problems, you're going to be given an expression, and then you're going to be told values for the variable. If I ask you to evaluate this expression that's right here, 9.99d plus 12.99c, if I ask you to evaluate it, you should have two questions for me. You should ask me, hey, what is the d? What is the value for that? And then what is the value for c? You can't really evaluate an expression, or you can't do much with it, if you don't know the value of the variables. When you know the value of the variables, what we're going to be doing is we're going to substitute those values in for those variables, and what that does is it turns it into a numerical expression. So you can see it right here. They start off on every evaluating expressions problem. I think you should write down the expression with the variables in it. Then what is done is they are replacing the variable d with 1.5, because it says there's 1.5 pounds of almonds, and the almonds went with the $9.99. So they put 1.5 in for the variable d, and then they put 2.5 in for the variable c, which is for the pounds of cashews at $12.99 a pound. So it's $9.99 a pound for 1.5 pounds of almonds, and it's $12.99 a pound for 2.5 pounds of cashews. And then this becomes a numerical expression. If the numbers were a little bit nicer, you could do this just manually, but if the numbers are messy, I don't mind if you use a calculator. If you typed it into a calculator, they take it to 3 decimal places here. Since this is a cost, the final answer is rounded to the nearest penny, or it ended up to the nearest penny. But sometimes when you do the calculation, it may go past the 2 decimal places there. Just round it appropriately. Since it's a dollars and cents thing, it makes sense to have 2 decimal places. So if you take $9.99 times 1.5, you get 14.985. If you take $12.99 times 2.5, you get 32.475. Put those together, you get 47.46. So if you were to go in and buy 1.5 pounds of almonds and 2.5 pounds of cashews, the price before any tax or anything would be $47.46. So the process is going to be write down the algebraic expression and then write the expression again, only you're going to substitute numbers in for the variable. So you have to know what those are, and we're told those numbers right up here in this prompt. And then it's just a matter of following your order of operations. The order of operations says that the multiplying, the product at the beginning and at the end, has to be figured before you can do this adding. So you have to multiply, and then the adding. But whatever operations are going on in the expression, you have to follow the order of operations. Now, I contend that you didn't have to be told this expression. It makes it a little more challenging when you have to come up with the expression yourself. So one thing you'll be expected to do is write expressions, but also after you write them, then you can do an evaluating, and that's going to be a later example where you write it and then you evaluate it for some value. So let's look at try it. For try it 2 here, and again, I would recommend that you pause the video and see if you can work out the problem yourself, and then watch the video to see if you work it correctly. So here we go. Try it number 2. The cost to rent a scooter is $15.50 per hour. That's very similar information to the cost of almonds being $9.99 a pound. It's $15.50 per hour. The cost to rent a watercraft is $22.80 per hour. And then it says to use this expression. And if you investigate this a little bit, 15.5 is just $15.50 without that trailing zero there and the dollar sign. But it's 15.5 times S. And the S is representing the hours that you're renting a scooter. I'm not a huge fan of the variable S because my S's look like 5s, but I'll make it a different height. It'll be okay. 22.8 has a W with it because that's $22.80 per hour to rent a watercraft. So W's for the watercraft. And we're supposed to determine what it would cost to rent a scooter for 3.5 hours and a watercraft for 1 3/4 hours. So the process is going to be rewrite the expression just as it's given. So I'm going to write 15.5 S plus 22.8 W. Then I'm going to write it with the value for S that I'm told put in there and the value for W that I'm told put in there. And since this is a number right in front of a variable, there's understood multiplying here. So this is going to be 15.5 times, and then it says the scooter's rented for 3.5. So it's times 3.5. Plus, and then I'm going to have 22.8, and that's going to get multiplied by the hours that you rent the watercraft, which it says is 1 3/4. And now it's just a matter of calculating that. I'm going to follow the order of operations. Any decent calculator has it programmed in, but be able to do things without a calculator. I'm going to type it into my calculator because the numbers are kind of messy here. But if the numbers are nice, if this was 15 times 3, there's no good reason why you can't do that without a calculator. I could do 15.5 times 3.5 and do manual calculation, but I'm just going to type it in. 15.5 times 3.5. And I get 54.25. So this is 54.25. Even though I could do the whole thing on my calculator, I highly recommend kind of breaking it down, following the order of operations. even though I'm using a calculator. That way we can figure out where things get messed up if you don't get right answers. 22.8 times, and then 1 3/4, I'm going to type it in as 1.75, and I get 39.9. So 15.5 times 3.5, I got 54.25, 22.8 times 1 3/4, I got 39.9, and then I'm just going to add those together, 54.25 added to that, and I get 94.15. And since this is a cost, I'm going to put a dollar sign with it. So it's going to cost $94.15, and then plus any tax that there might be. It might be tax-free, who knows. So write the expression, replace the variables with the numbers that you're told, and then follow your order of operations from there. So that's the process you should do on each one of those. Write the expression, then you do the subbing in, and then you follow your the order of operations, the PEMDAS. And so there we go. Let's move on to the next set of examples. Example 3, we're actually going to do both things that we did. On example 1, we wrote an expression. Example 2, we evaluated an expression. Example 3, we're going to write and evaluate. We're going to write one, and then we're going to use that expression to evaluate. And this is example 3 all worked out. I'm just going to kind of go through it so that you understand it. So here we go. Example 3, write and evaluate expressions. Malik and 2 friends earn M dollars in 1 week doing odd jobs. They split the earnings so that each friend gets 1/3 of the total earnings. So they earn M dollars, and they each get 1/3 of that. And then Malik uses $32.50 of his earnings on lunch each week. And then last week, the 3 friends earned $963. How much money did Malik have left after paying for lunch? So let's kind of break this down. The first thing I'm going to do is I'm going to take the information from this problem and see where this expression comes from. So it says write an expression to represent how much Malik has left. So the M is the money that all 3 of them got. It is the total earnings. So Malik only gets 1/3 of that. So it's 1/3 of the M, the total earnings. So 1/3 M is what Malik gets. But it says he uses $32.50 of that on his lunch. So that's going to take away from the money that he has. So 1/3 M is the money one of the 3 gets. But then Malik spends $32.50. So that is being taken away because it's going away from him. He's having to spend that money. And so this right here is the expression to represent how much money he's going to have left. He gets 1/3 of the total earnings, but then he also spends $32.50 on his lunches during the week. Then we are told how much they actually earned. We're told the 3 friends earned $963. So what we do at that point is we take this expression and we replace this money variable, this M dollars, we replace that with the $963 that we're told right here. And then if we do this calculation, we multiply first, because multiplication is done before subtraction. You multiply 1/3 of 963 is 321. So it's 321. I would like to actually see that in some work. 321 minus 32.50. And if you do that arithmetic, you get 28.5. And so then that is a dollar and cents sort of thing. So the final result is Malik had $288.50 left after paying for his lunch. So all 3 of them earned $963. Malik got 1/3 of that, so he got the 321, but then he had to spend $32.50 on lunches, so we take that away and he ends up with $288.50. So let's move on to the try it number 3, and again, try to pause the video and see if you can do it on your own before I work it out. So here we go. Amelia earns $8.74 per hour plus a gas allowance of $350 per day at her job. how much does Amelia's job pay in a day? So it's in a single day. So she's only going to have to pay this $3.50 once. Or only going to get that $3.50 once. She's going to get $3.50 per day, but then it says a day. That's just one. So she's going to work 5.5 hours, and it says write an expression and evaluate it. So let's do it. It's two parts. We're going to write an expression, and then we're going to evaluate it. One thing that's a little bit different on this is we are not told a variable to use for the number of hours. We don't initially know the number of hours. We're told that in the question here, but in this first sentence, we aren't told the number of hours. So I have to pick a variable for that. I think H is a good choice for that. So I'm going to use the variable H to represent the hours. So she's going to earn $8.74 per hour. So it's times the number of hours. But then she's also going to get plus $3.50. And she's only going to get one $3.50 payment because it's per day, and then it's how much does her job pay in a day. That's singular. So if it was for multiple days, I would put maybe D for days there, and then we could do that multiplying, but it's just for one day. I suppose I could go ahead and put the D and then replace it with 1 for that, but I'm going to keep this nice and simple. So there is my expression. She's going to earn $8.74 per hour plus $3.50 for gas allowance. So there's the expression. So that's that part. And then we are asked, how much does Amelia's job pay in a day when she works 5.5 hours? So this is the H. So we're going to take 5.5 and replace that H with that 5.5. So it's going to be 874 times 5.5. And I'm going to write that as 5.5 plus 3.50 for the gas allowance. And again, if the numbers were nicer, we could follow the order of operations and do that manually. I'm going to type it in, but I am still going to try to show a step here. I'm going to take 874 or 8.74 times 5.5, and I get 48.07. 48.07. So that's this part right here. I multiplied before I do this adding, and now I'm going to do the adding on of the gas allowance. So just plus 3.5, and I get $51.57. And so I'll put some labeling on that. So there we go, $51.57. So $8.74 for 5.5 hours, plus $3.50 a day. So plus the $3.50, and that's $51.57. So let's look at the summary page here. The key concept: algebraic expressions can be used to represent the problems. If you don't know something, you're going to replace it with a variable. You get to pick on some problems. Some problems, they will tell you what variable to pick. It never really matters as long as you understand what the variable that is being used, what it stands for. So I know some kids that use X for everything. If it's hours, they use X. If it's days, they use X. If it's kittens, they use X. They don't care. They use X every single time, and that's totally fine as long as they understand what that variable represents. And then when you have an expression that has a variable in it, you can't really do much in terms of evaluating it until you know what that variable is. So that's another thing that you'll be doing is you'll be finding the value of an expression when I am told the value of the variables. And how that works out is you write the expression, then you replace the variables with the number you're told, number or numbers, and then follow your order of operations. So you are expected to have a sequence of steps there: expression, substitute in values for the variables, and then follow your order of operations. So if all you're doing is writing down answers on those, that is nonsense. We have to make sure we show what we're doing there. It'll help you figure out what you're doing wrong, and it'll help me figure out what you're doing wrong. So the plan is on this particular topic, we're going to go over notes. You'll have video examples in case you are a little slow taking notes or didn't understand as I went through it. And then we'll have some problems. I chose a few more problems than normal in this particular lesson because they don't take very much time at all. And so I don't think it'll be a big deal that there are a few more problems. So the homework on 4.1 is numbers 4, 5, 6, 7, and then 12, 15, 17, and 18. As always, check over your homework, ask questions on homework, double check that you're doing things correctly. So let's try to kick up the value of our homework significantly. If you do your daily homework to the highest possible quality level, that'll really help out with your quizzes, which will really help out with your tests later on, and things will just kind of take care of themselves. In class, you'll be able to finalize and work through your homework, and then you'll be taking a quiz. And then in this topic, there are no more Math Excels to fix low quiz scores. You'll have to actually do additional practice problems, which is basically like extra homework if you want to improve your quiz scores. So that is lesson 4.1.